Hello everyone, welcome back. In this walkthrough, I will demonstrate a complete digital forensics workflow on an iPhone 17, including data acquisition, artifact analysis, and IOC-based threat detection. This is a safe lab environment. I'm going to store all forensics data on an external SSD with read-only access to prevent any changes, and I will perform all analysis inside an isolated virtual machine where Mobile Verification Toolkit will run, keeping everything contained and protecting the original data. So before we start, let me show you and explain to you how I set up this lab and what kind of software and hardware I'm using for this project. So let's start. Okay, here we have 5 main components of this lab. Commercial data extraction software, UTM virtual machine, open source mobile verification toolkit, 1 TB external SSD, and MacBook Pro. Before we move on, let me quickly give you more insights for each of those. For data extraction, I'm using Elcomsoft iOS Forensic Toolkit, or EIFT, which is a professional forensic tool that allows me to collect data directly from the iPhone, including system information, backups, and user data. With this software, we can extract full iPhone backups, which is logical acquisition. We can collect user data such as photos, messages, and app data. We can get a device information like iOS version, hardware, or battery. We can also dump accessible file system data, AFC data, extract crash logs and system artifacts, list all installed applications, and we can support different acquisition modes like normal, agent, and jailbroken. For this lab, we are using normal mode. Okay, here is my UTM virtual machine, and inside this virtual machine for analysis, I'm running a Mobile Verification Toolkit, or MVT, which is an open source tool developed to detect traces of spyware like Pegasus by scanning device backups against known indicators of compromise, or IOCs. So before we start doing any analysis, once we collect all data from iPhone and store that data on this external SSD, we have to mount this SSD to this virtual machine. And as you can see, there is nothing inside here except these things. They come with the external SSD. But once we create those directories and store all data from this iPhone 17 Pro Max, then we can mount the SSD to virtual machine and start doing analysis. And finally, I'm using very powerful laptop MacBook Pro with the Apple M4 Pro chip, 48 gigabit of unified memory, and a 20-core GPU. This allows me to handle large forensic data sets and run analysis tools smoothly. So we use a safe lab environment to keep the original data unchanged, ensure forensic integrity, and isolate the analysis to prevent any contamination or accidental modification of evidence. Let's move on. Okay, so the first command I will not run because I don't want to reveal some sensitive information about my device. But basically, this command retrieves detailed information about the connected iPhone, such as model, iOS version, and status, and also the status of EIFT software that we are running to extract data from iPhone 17. So this one we will run to create some subfolders. So let's do that first. Okay. So running this command, we are creating iOS backups clean. So we will use to store clean iOS backups in this subfolder. And the other one is called Digital Forensics and Incident Response /MVT. So this subfolder we will use for analysis output. And I think the main directory, it's called Nermin, which is my name. And let's check that. Yeah, as you can see, the main directory is called Nermin. And if we double click, we can see we have 2 subfolders. And let's verify one more time. Yeah, there we go. Okay, let's move on. So the next one, it's confirming devices detected. Again, this will display the unique ID of any connected iOS devices to confirm detection, and I don't want to run this because it will again contain some sensitive information about the device. But we can run this one, pairing device, and if I'm not wrong, when we run this command, we have to unlock the iPhone and click allow, which means like we agree to give the access to this tool. Yep, I think, yeah, it says trust this computer. Yes. Let me put my passcode. Okay. Run again. Okay, it says success. Paired with the device, and here's the number of the device. Okay. We can move on. Okay, so the next thing, we will create one more subfolder, which is AFC/dump. Okay, so this will, so basically we just created one more subfolder to store AFC user file system dump. Let's move on. Okay, so now we can run this command. Just paste this. So this will perform a logical acquisition of accessible user data, and it will save everything as a key. Put password. Okay, so right now we are collecting all AFC data. It might take a little bit time. Okay, it's done. Now let's verify the dump file exists and see its size. So to do that, we can run this command here. And as you can see, we successfully created AFC dump and collected all accessible user data. And we have 49 gigabits of collected data. So now we can enable encryption. And basically I have done this. I don't want to repeat this process because my password is already set up, and if I try to do that again, then I have to first remove the old password, and it might take a little bit time. So but this first command enables encryption on the device backup for more complete data extraction. And then the second one, it's same thing, turns on backup encryption interactively for the connected device. Or we can just disable backup encryption if needed using this command. Again, I'm not going to do that because it's already done, but we can move on, and we can now create a full logical backup of the iPhone to the external drive using this command. Okay, it might take a little bit of time. Let me just put my passcode. There we go. There we go. So now let's list all backup files with their sizes to confirm the backup was created. And we can run this command here. Okay. So we have total 256 files. Okay, let's move on. And actually we can use this one basically to see the contents of the specific device backup folder for just for inspection. Let's do that. There we go. Let's move on. Okay, so this command we can use to check total backup size. So basically, as you can see, it shows the total size of the iPhone backup directory, which is 62 gigabits of only this one iOS backup clean. Okay, now we can collect some device general information. So basically we will use some of those commands to extract some metadata. And the first command, this one right here, so this command will pull current battery related device information, and it will save everything in battery.txt file. But before we run this command, let me quickly show you something here. So basically those tools here, or the part of the library mobile device, which is an open source toolkit that enables communication with iPhone over USB. So basically this allows functions like device pairing, backups, and information extraction. So those tools are leveraged by EIFT software to perform forensic data acquisition. So let's run the first command, and everything is saved right here, battery.txt, and later we will analyze those data. Let's run the next one. So this one will list all installed application. So this command will export a list of installed applications from the iPhone to a text file. Okay, well, see. So now we will create some subfolder. So this subfolder will be used to store crash reports collected from the device. Let's create that. Okay. And now we can extract some crash logs. Okay, so this command will extract iPhone crash logs and save them into the crash report directory, as I said. Okay. Let's see what it says. Okay, it says it's done. Okay, and now we can use this command to list the contents of the iPhone backup and save the file index to a CSV file. Okay, now we can run this command to compare the sizes of our main acquisition artifacts to quickly see how much data each one contains. So let's do that. Okay, so as you can see, we have 49 gigabits of AFC dump, 62 gigabits of iOS backups, and we have 49 gigabits of additional data stored in a DFIR subfolder. So according to this, we have collected 160 gigabits of data from iPhone 17, which is not true. So this iPhone has occupied 90 gigabits from 1 terabyte. So there is no more than 90 gigabits altogether data stored on this iPhone. This means that some of those data overlap, and it can be because we run some commands that can collect the same data. So basically we have some double data. So I would say probably somewhere between 65 to 75 gigabits of useful data collected from the iPhone 17. And so I have done some research about Elcomsoft iOS Forensic Toolkit, and I found out that this tool can probably collect no more than 85 to 90% of data from iOS devices. And I guess in order to collect 100% from the iPhone or any iOS device, we have to use the version that it's available only for law enforcement. So anyway, so let's say we have probably somewhere between 75 to 85% of useful data from iPhone 17. So let's move on. Now we can start using our UTM virtual machine and run MVT to analyze all those collected data. So let's do that. Remember at the beginning I mentioned that we have to mount this external SSD to our virtual machine in order so we can run some forensic tools inside the virtual machine and get access to data that we stored on external SSD. So let's do that first before we move on. So we can go here, edit, virtual machine, go to sharing, browse, and as you can see I already have done this. Here's my directory, read-only access, save, and now we can run a VM. Let me just log in this virtual machine, and then I'm going to SSH to this virtual machine. And don't ask me why, I know it's really stupid, but trust me, it works much better this way. I don't have time to explain this, but maybe some of you already know what's going on right here. So anyway, we are in. Let me quickly SSH. this a little bit bigger. Oops. Okay. Okay, let's do it. Okay, so the first thing we are going to change into the tools directory where our DFIR utilities are stored, and then we will activate the Python virtual environment for running MVT. Okay, so now we can decrypt the encrypted iPhone backup so MVT can analyze its contents. Let's do that. So we can run this command. Okay, so this might take probably 25 minutes to decrypt all 350,000 files. And I'm going to type in my password and decrypt everything, and once it's done, I will come back. So I will pause this video and then come back when everything is decrypted. Okay, here we go. Okay, file decryption is done. Now we can list the decrypted backup files to confirm the decryption worked. And I can tell you it took about 25 minutes to decrypt all those files. And if I'm not wrong, we decrypted over 350,000 files. Okay. And we can run one more command, just double check. We are going to check the backup data file type to confirm the backup is readable and again decrypted. Okay, everything looks fine. Let's move on. Okay, so now finally we can run MVT against the decrypted iPhone backup using Novent spyware IOCs and save the results. Run this one. There we go. Okay, here we have installed applications, so you can see all those applications are installed on my iPhone. We have some iPhone information. Let's see what else we have. We have some browsing data. Yes, so many things. I will not go over those data in detail. I just want to show you how this works. Okay, now we can look for Pegasus malware, and I can tell you 100% there is no Pegasus malware on my phone, because this malware cost millions of dollars and nobody is going to spend that much money on me because I'm nobody. But let's do this for fun. So basically we are performing a final MVT scan specifically to detect Pegasus indicators in the backup, and as you can see it's working. So now let's list the IOC files used for detecting Pegasus and other spyware. Okay. Okay, and then we can move on. So now we are going to extract and clean all Pegasus related domains from the STX file into a list. And as I said, there is nothing in this file, of course. Okay, let's move on. So we can now show a preview of extracted Pegasus domains and count how many Pegasus IOC domains are in the list. Running this command. And those are Novent C2 infrastructure domains used in past campaigns. And if I'm not wrong, we loaded over 10,000 IOCs to scan full iOS backup. So basically MVT is trying to match these against my device artifacts such as Safari, SMS and logs. But again, there's nothing. So we can move on and extract all unique URLs from Safari history for analysis. Running this command. Okay, nothing there, right? Let's move to the next one. So now we can search the timeline for any Pegasus domains, like broad match. Many of those include false positives, but let's do that. Let me clean my screen first. So there is going to be a lot of data and we have to do this manually. Again, I will not spend that much time on this. I will just move on. Again, this is just to show you how this works. But yeah, let's move on. So the next one, we will perform an exact match checking to confirm if any Pegasus domain exists in my device activity. I'll run this one. Okay, let's see what we have here. Again, a lot of data. Okay, so let's run this one. So this will basically extract all unique domains from the timeline for kind of precise comparison. And now we can also check IOC output. So this will list all files generated by the MVT scan for investigation. Okay, there is nothing. Okay, there are so many files here. Okay, let's move on. Okay, now we can display any confirmed spyware detection found by MVT using this command. Okay, so we are getting error because there is nothing there. That's why it says no such file or directory. This means there is no any detections found by MVT. This is normal. Let's move on. The next one, we can search the MVT log for any signs of detections or suspicious activity. Okay, we can use this one. Okay, again, we have so many data here. So all this must be reviewed manually, and it takes so much time. So again, we will not do this here. The next one, we can check if MVT created any files indicating matches or detections. Okay, there is nothing. Okay, now let's review configuration profiles for malicious MDM or suspicious settings. Okay, we got something here, but nothing suspicious, right? Okay, let's display app permissions to check for unusual or excessive access. Okay. Okay, now we can filter for sensitive permissions that could indicate spyware behavior. Again, we're getting something. Okay, let's review now Safari history for suspicious links or exploit delivery attempts. And we can run this one. And again, we're getting some data. So now we can analyze WebKit activity for signs of browser-based exploitation. Again, we have some data. So we can now check SMS messages for phishing links or malicious content. So this command will show the beginning of the timeline to understand its structure, and it will show the most recent activity recorded on the device. Okay, and the next one will search the timeline for keywords commonly associated with exploits or suspicious behavior. Basically searching for some keywords. Okay. Yeah, we have a lot of things here. Okay, and this one will search the MVT log for any detection or warning keywords and show the most recent results. And finally, the last command on our list, it's a summary of which forensics artifacts contain the most data. So this will count lines in all JSON files to identify which forensic artifacts contain the most data. And that's all for today. Thank you for watching. Again, I didn't go in details analyzing this data because it takes so much time, and so many things needs to be done manually. And again, if we do that, the video will be for a few hours. So, but I just wanted to show you how that works, like how you can set up the lab, how you can extract data from iPhone on external SSD, and how you can run some of those tools like MVT to analyze some of those data. This is just a fraction of what we can do actually here, but again, this is just to show you quickly how that works, like in digital forensics. I might make some video going more in details about Elcomsoft iOS Forensic Toolkit, so maybe I can do that next time and show you more details about that tool. Thank you for watching, and I will see you in my next video.